In this session, we are going to see Introduction to Pandas. I am going to use Jupyter Notebook throughout the session to do the hands-on. Okay, a quick introduction. What is Pandas? Pandas is the open source library which helps for analyze and manipulate the data. Pandas is the Python package built on top of the Python programming language. It is fast, powerful, flexible, and easy to use. Why Pandas? It is integrated with many other data science tools and machine learning tools. It is used in machine learning model pipeline for analyze raw data and pre-processes it. Here is our machine learning model pipeline. Here in step 2, we have to do data analysis on raw data, and step 3, we have to perform pre-process activity to train the machine model. Okay. We have already seen this machine learning model pipeline in our first session. What is machine learning with real world example? You can find it out in our YouTube channel, Digital Academy. Course name, What is Machine Learning with Real World Examples. Okay, let's do the code. Okay, as a first step, we have to import Pandas module into our Jupyter notebook by using keyword import. I am adding command on each cell for your future reference. Import Pandas. Okay, import Pandas as I am added alias name for pandas module. Okay, pd dot. I am going to use version attribute to find out the version of pandas 1.0.5. You can check it out the latest version in our pandas official site. The latest version is 1.0.5. So we are going to use the latest version in our hands-on session. Okay. You can also import the pandas without the alias name. Okay. PAN and check the version with our attribute double hyphen double underscore version double underscore. Okay. Both syntax are correct. Either you can use alias name or without alias name you can use directly by pandas module. Okay. In this session I am going to use alias name for pandas module. Okay, fine. Section 1, data type. In pandas, we have two data types, series and data frame. Series for one-dimensional column of data, and data frame two-dimensional table of data with row and columns. Okay. First data type series and another one is data frame. Let me visualize these two data structure. Okay. So here is our first data type series with the column of data Monday to Friday and the index 0 to 4. It's the default index for series. Okay. And the second data type data frame, here is our data with row and columns. Okay. The name, age, dress code, gender index for column with axis 1. Okay. And the index 0 to 6 for row with axis 0. And the both data types are object. Okay. This is the visual structure of series and data frame. Let's create the same structure in our Jupyter notebook. Okay, for both data type series and data frame. Okay, first create series. We have to use pandas for creating both data type series. Here you have to use S capital for series function. Inside that you have to pass the content of data in list format. Monday, Tuesday, Wednesday, and Thursday. Okay, let's see. So you can find this same structure which was on saw in our Excel sheet. Okay, Monday, Tuesday, Wednesday, Thursday, and the index is 0, 1, 2, 3, and the data types are object. Okay, the data type is object. Okay, let's create data frame. So again, data type. You have to use the model pandas and the data frame. Here, D and F are capital. We call the function data frame. Here, you have to pass the content of column and row value in dict format. Okay, Dictionary is dictionary format. Here, you have to pass the column name, Modi, model search. Let's take three. Okay, Modi, search, and model. And then again column age. Let's give some random value. 10, 20, 10. And the dress code. Here is dress code. I'm going to give shirt. 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 And then let's see the data. See here the index axis 1 for row and the column axis 0 and the index 0, 1, 2 and the name, age, dress code are the index for column. Okay, you could find a similar structure in Excel. Okay, okay, fine. Let's create another two series. I'm adding command here. Okay, I'm going to copy and paste the code from the previous cell, but you guys don't do that. Do more practice by typing the code. Later, you can copy and paste. Okay, I'm going to copy this one. The create series. Copy. And I'm going to assign this series into the variable. Okay. Details. Details. And printing it. See? That's it. Okay, fine. Let's create another variable. Month. Okay. And I'm going to pass month in the list format. Okay, fine. January, February, March, and April. Let's see the month. Okay, fine. I am the caps. Okay. We got two series now. Let's combine these two series into the data frame. Okay. I'm going to create the data frame with these two series. Data frame with above series. Okay. I'm going to create ed.data frame. We have to pass dict Python dictionary for creating the data frame. Weekday, weekdays, and month. Month. See, you have combine the series into the data frame. Okay, this is fine. Okay, let's create same series with different index. Okay, I'm creating series without default index. In this case, we are going to create the index value for each value as a. You can define any value, but I'm going to use alphabetical order A, B, C. There is no order in it, but you can define anything as you wish. Okay, it's D and Z. Okay. Also, I'm going to create the index for the second series. 1, 1, 2, 3, and 7. 37, 67. Okay, that's it. Print the week, weekday, and month. Okay, here the default index has changed to A, B, D, and Z, and here 1 to 37 and 65. Okay, now we are trying to join these two series into our data frame. dd dot data frame. Here weekday. Here we have to pass the next weekday. Weekday and month to month. See, here we got different output. Why? The reason is here we have the default index 0 to 3 in both series. So when we try to join the two series into the data frame is try to find the index in both series, and if it find, then it's joining the two index to create the data frame. But in our case we have different index, but the index A, B, C, sorry, D and Z is not in the series data type month, but here we have 1, 2, 37, 65. So this index is not in our weekday series. So it's combining each cell with different value. Let's see here A, B, C, D with, and the relevant month series with blank value. It's a null value. Okay, here in weekdays here null value, and here is appending with the month value. Okay, fine. I have created another data frame for car model price from the scratch. Okay, I have created 4 series. Series is the one-dimensional column, so you have to pass the content of the column should be in the list, Python list format. I have created 4 series. Okay, and then car model price is the data frame. You have to pass this series in the dictionary format to create the data frame. Okay, I have passed in the dictionary format. There, I'm going to print now. Okay, yeah, this is nice, and we got our new data frame. Okay, fine. Let's move to the next section to import and export data. Okay, fine. Creating series and data frame from the scratch is nice, but in real scenario, we are not going to create any data types from the scratch because these data types are mainly used to handle more data. Okay, you may think now, how are we going to create? There are lots of way and functions are in the pandas to import the data from outside world into our Jupyter notebook. Okay, so one of the best way to import the data is CSV file. Okay, there are Other file format is also there, but in our scenario, we are going to see CSV file. Okay, I have some sample weather data in the CSV file, and I have also placed it in our Pandas Jupyter home directory. Okay, here weather.csv. Okay, fine. So I'm creating the data type for this data frame, weather.df, and pandas. You have to use that function by calling the pandas alias pandas. Okay, read. Okay, here as I said, we have read CSV, read Excel, read HDF, HTML, JSON. Okay, these are all the format which are available to import the data from the outside world into our Jupyter notebook. Okay, now I am going to use read CSV. And we can simply pass the file name because we have uploaded the file in our home directory. Okay, data CSV. I'm going to print that data. Okay, see here we have imported the entire data in the CSV file. This file has 25,000 rows and 25 columns. So if you try to create this entire row and column data into a Jupyter notebook from the scratch, it may take an hour. So within a second, we just imported all the data from the CSV file. Okay, this is nice. Okay, now export the data. Imported data. Okay, weather weather.df.csv. You have to mention the file name where you want to export it. Okay, I'm going to use dump. Okay, that the same format. See, I have exported successfully. Let's check. Okay, I have imported the file 1250 and 1250 as just a minute ago. Okay, okay. Here is our exported data, and here is our imported data. You may find some difference in here. Okay, here the first column is index and the second column is date and third column is location. But in our exported data, weather dump, we have some blank column and then the index, date and location. Okay, this is the column which happened in the prefix. This column denotes the index. So here you can see that index. Okay, when we import the data in the CSV file, it got created with the index in our Jupyter notebook like 0 to 25,000. So when you try to export the data, the index column should also get append in the prefix. Okay, if you don't want that index in the exported file, then you have to mention the index command with false. Okay, let's see now. You got permission didn't because we have opened it here. Okay, how to close the exported file by the term. Okay, fine. Let's rerun this cell again. Now it's successfully. Let's check the file again. We got our file 1252 and the time is just a minute ago. Opening. Now see, we don't have the index column in the prefix. You can also check the imported file. Both are looks similar. Okay, this is fine. This is how you have to import the file from outside world into the Jupyter notebook. Also, you can export the data from the Jupyter notebook to the any other file format. Okay. This section will explore the data frame weather underscore df. First keyword dot shape. Data frame dot shape will return the number of row and number of column in the data frame in a tuple format. And then okay, next keyword dot info. This DataFrame.info will display some high-level overview about the data frame, like the object name data frame and the entries in the data frame 25,000 and the index start from 0 to end with 24,999 and the total column count 25. Okay. Also, it describes the index name and column name and non-null count for each column and the data type for each column in the data frame. Okay, and a dot info is one of the easiest way to identify the blank value in the data frame for each column. This is the important steps which we need to take care in the machine learning model pipeline. Okay. Okay. Step 3. It is the steps in the machine learning model pipeline to build the machine model. Okay. As part of these steps, we have to make sure that the data frame should not contain any blank value or any outlier in it. Okay. Okay, and this we discussed in our previous session in our YouTube channel, Digital Academy. The course name is "What is Machine Learning with Real World Example." You can check it out in our YouTube channel, Digital Academy. Okay, let's back to our original section. Okay, moving to the next keyword. Okay, dot describes data frame. Dot describes will show some high level statistics detail about the data frame for each column like count, mean, the average, standard deviations, minimum, and the average data for 25 percentage, 15 percentage, and 75 percentage. Also, it displays the maximum value in the data frame for each column. Okay. Then next keyword dot columns. Dot column will return the columns and the object of the data frame. If you want data in the tuple format, see the first object in the list and the second is the keyword argument in our list. Okay, if you want to convert the tuple into a list, then you have to call the list function to convert the tuple value in the list format. Okay, we got our column name in the list format. Okay, moving to the next keyword. Okay, here print the column value. Actually, here we have two different types to print the column value. Okay, by using data frame dot column name, you can display the column value, and then second way is in the square bracket you can mention the column name. Data frame square bracket the column name. Okay, and the first way you can't use when the blank the column has some space in between. Okay, for example, let assume the column has rain and a space tomorrow, then it won't work. You have to use the second option to display the column value likewise. And one more additional benefit over the first way is you can display n number of column in the second method, but we can't do it in our first way. For example, you can pass the column value in the list format in the inside the square bracket. Data frame square bracket inside you can pass any number of column name. Okay, then you can be able to display the multiple column in on the same time. Okay, and then some of the Python function. Okay, first dot sum. So data frame dot sum will display the sum of each column value. Okay, it may be a float or integer or string. It doesn't matter. It will sum up the value integer and float in the float format. And if there is a object, date object or string, then it append each value into a single value. Okay, that's all. The next keyword dot mean. Here It will sum only the integer and float column in the data frame. Okay, the index. So the rain column which was used in that sum keyword, but here it not used. See, you don't have any rain tomorrow keyword. Okay, column. Okay, let's move to the next keyword, length. So here it is used to find out the number of classes present in our data frame. Length 25 classes are there in our data frame. Okay, and the last one, dot index. This will display the output into full format and it shows some detail about the index, start, stop, and the steps. Okay, that's it. Let's move to the next section, view and selecting the data frame. Okay, to display the top 5 row in the data frame, we have to use dot head. Okay, dot head function, data frame the dot dl. This will display the top 5 record. Okay, fine. If you want to display top 10 record, then you have to override the default value for the head function 5 with 10. Okay, now you can able to see top 10 records in our data frame. We also have tail method to display the bottom record. Okay, whether data frame dot tail. Here also you can override the default value 5 or you can simply call the tail function. Okay, override the default value 10. So here you could see the index for the bottom in the data frame record. Okay, fine. In this session, we are going to see two important operations in the data frame: dot location square bracket and dot index location square bracket. Okay, dot location square bracket is used to extract the data from the data frame by using the user defined index. Dot ilocation, index location is used to extract the data from the database by using the system index. Okay, let's see in action. Okay, let me copy some comments from above for creating the series and data frame. Okay, let me use this command for creating the series. Let me remove the non series. I'm going to display the okay. We got our series data type. Okay, the object is data type. Okay, now we want to extract the data when nested from the series data type. You have to use dot ilocation. Okay, day dot location. Okay, dot location square bracket. Here you have to pass user defined index. If the user defined index is not defined, then you can pass the system index. Okay, here Wednesday is our P. Okay, let's see. It's displayed. Okay, fine. Okay. Now you try the dot ilocation. See, here it's a user defined index. Okay, what is the system index? System index is simple. Start from 0 to 2 and it goes on. 0, 1 and 2. Wednesday is the 2 integer value. Okay, you have to pass the to display the Wednesday. Okay, that is the difference between dot location and dot index location. Let's see another example in data frame. Let me copy some data frame creation logic from above. Okay, this I'm going to use. Okay, copy and paste. I'm assigning this data frame into the variable. Yeah. Okay, fine. Now I'm going to extract the. Let me display first. Okay, I'm going to extract the search in row. Okay, the index one. Okay, what you have to do for location, you have to pass the system user defined index. If user defined index is not there, then you can pass the system index. Okay, at location. We got our Sachin row. You can also use at iLocation to display the I index. Okay. Now we have to pass system index here. Here also one. See, we got our Sachin row. Okay. You can also try slicing concept in dot iLocation because in dot iLocation is a user defined index. We can't use slicing concept, so you can try the slicing concept in dot iLocation. Let me try that as well here. Okay, I'm going to extract the data 1 and 2, Sachin and Nodal row. Okay, df dot iLocation. Okay, iLocation starting is 1, so you have to mention 1 and end with 2 and then you have to 3. Okay, see Sachin and row. Sachin row and Nodal row, we will get it. Same way, you can also use that slicing concept for series. Okay, series. Where is our series? Here you can display Wednesday and Thursday. Okay, weekday 0, 1, 2. Start position is 2 and end position is 4. Okay, weekday start position dot location. Start position is 2 and question is 4. See, Wednesday and Thursday. Okay. Okay, fine. Let's move to the next section. Conditions and some operation in data frame. Okay. I have created a new data frame car model price. I have used 4 different series to create the car model data frame. Okay. Car model, car color, car price, and car door. Okay. Please make sure that when you create any data frame by using series data type, then all the series which we are going to use in the data frame should the index should match each other. Okay. Okay. I am displaying it here. Okay. The section condition. Okay. Condition is nothing but the same as uh, all programming language. We have to extract the data based on some condition. Okay. Now we are going to extract the row based on the car model. The car model which falls under the Hyundai. Okay, for example, I'm going to extract the data from the car model price, car model Hyundai. Okay, see, I have extracted the data. The car model has Hyundai. Okay, condition comes to the next. Pandas dot cluster column 1, column 2. So if you want to compare any two column in the data frame, then the best way is to use dot cross tab. pd dot cross tab. Inside the bracket, how to mention the column name. I am going to compare car model and car color. Car model and car color. Okay, let's see. Here is our color and here is our car type. Okay. In Hyundai, we have 2 red color. Volvo, we have black color. And Ford, 1 black color. And Maruti, 1 yellow color. Okay, fine. So, the same manner you can compare any column in the data frame by using dot cross tab. Okay, then moving to the next one. Dot group by column dot sum. So if you want to group any particular column and you have to perform some mathematical operation like mean, sum, or average, best way is to use dot group by function. Okay, let's data frame car model price dot car door. I'm going to use dot. I'm going to or model. Okay, or model sum. Okay, see, only the sum and medium or average, those function is applicable only for integer and float. So it sum the corridor for each category. Okay, that's it. Fine. Let's move to the next section. Here we are going to see data type conversion. Data type conversion. Okay. To do that, we need some data frame. I'm going to use car model price, which we seen in the previous step. Okay. This is our data frame which we are going to use for the data conversion. Data type conversion. Okay. Also, I'm going to find out the data type for each column by using info command. Okay. Car model price and info command. The first three columns are object data type and the last one cardor is integer data type. Okay, fine. Now I'm going to perform two actions. The first action is I'm going to convert the car model value to lowercase. Here you could see, right, the first characters are capital for each model, Hyundai, Ford, Maruti. Okay, I'm going to convert from uppercase to lowercase. Okay, fine. And then the second task I'm going to perform the sum of the car price column in the data frame. Okay, sum of car price column in the data frame. Let's take the action. Okay, first we are going to convert from the uppercase to lowercase for the car model. Okay, car model price, inside that the column name, car model. Okay, see, here we have uppercase. Okay, we have to use some function to convert the upper character to the lower character. So what can we do? So we have in Python programming language dot lower. Do you remember that? Okay. Also we have n number of functions to perform different actions in the for the string data type in the Python programming language. Okay. But in data frame we have object data type. So as a first step, you have to convert the data type from the object to string. To do that, we have to use simple syntax dot str, which denotes the string. Okay. Now we have converted the object data type to string. Now you can simply perform an action by passing lower. Okay. Same as the Python programming language. So to do that, it will just simply convert the uppercase character in the word to lowercase character. Okay, see, all the character has changed to lower. So it won't update the actual data frame. To do that, we have to assign the value to the actual database column, data frame column. Okay, see, I'm going to print the data frame. See, the value got update in the data frame. And then second task. Here we are going to sum the column value in the data frame. Car price. Okay. Here also we can use integer function sum. Okay. But to do that we have the integer data type. But in the data frame we have car price as object. So you have to convert to the integer so that you can simply perform some action. Okay. But when you want to compare some value to the integer, then the value should be the number. If it is not, then you will throw some error. Okay, same as the Python programming. See, here we have three symbol dollar, dot, and comma. So first you have to remove this three symbol from the value so that we can easily perform the conversion from object to integer. Okay, to do that we have one function, replace, string replace function in Python. So we are going to use the same function here. Okay, the data type, data frame, car model. The column name is car price. First, we have to convert to the string str. Okay, string. Fine. Replace function. The replace syntax is same as the Python programming language. You have to pass the value which you want to replace and the value which you want to put on the replaced place. Okay, I'm going to pass in the list format with the forward slash in between for each symbol. First, the dollar symbol slash dot slash comma. I'm going to put the blank value or replaced value. Okay. Now the value has changed. Also, we are going to perform another action on the same statement, conversion data type. Okay, as data type. Okay, so this is the command which converts from the string data type to integer data type. Okay, see, we got integer value. Okay, to update the actual data frame, you have to assign it to the column. It's done. It's updated. Our model price. Okay, sorry, we can't use in the same cell because we have already updated the value string to integer. We are trying to run the cell again, then it throw an error. This string operation will applicable. See, can only use string for the string value because we have already run the cell and we converted the column type from object to string and string to integer. So we are again we are trying to perform another action by rerun the cell. So we got an error. No issues. We can just create another cell below and check. Okay, the data frame. See, yeah, that's why we got an error. It's unable to create the integer value in the string format. Okay, fine. This is fine and it's acceptable. Okay, it's a valid error. Don't worry. Okay, and another action here, the car price is not same as the actual one. Here you see we have $5,000, $7,000, but here it appended with 20. You have to remove. So to remove that, we can simply pass the car model divided by 100. By dividing 100, you can just reduce the last two zeros. Okay, car price equal to car price column divided by 100 and assigning it to the same column. Okay, fine. Let's check the data. See, now we have converted to the integer data. Now you can simply use column name car price dot sum. See, we got our total value. Okay, okay, fine. We have completed the task 1 and task 2. Okay, fine. This is our last section in this tutorial, some important function. We are going to see dot drop na dot fit na function and keyword in place and date parsed. So, okay, to do some answer on this function and keyword, we need some data frame. I have created the data frame df underscore blank. Okay, this data frame has some blank value. NaN denotes blank value in the column. Okay, fine. Let's do the code. Okay, first we are going to see drop NA. Okay, drop NA. Data frame df underscore blank dot drop NA. Okay, drop NA. See this function drop the blank row in the data frame. Okay, fine. Let's check the data frame again. Oh no, it's not removed the row from the actual data frame. So how we can update the data frame? Okay, in previous example, to update the column, we have used column name to update the column value in the data frame. But here we are trying to update the entire data frame, right? We are removing the row in the data frame. Here we can't simply add the data frame before to update it. Okay. So to do that, we need some function, right? Here we have keyword in place. In place to so to pass through. Okay. Let's check. Okay. Now I have updated the data frame. Let's check the data frame again. See, now it's removed. Okay. So the in place function is used to update the data frame. Okay. And drop NA is used to remove the blank value from the blank value in the row, the entire row from the data frame. Okay, fine. Let's check the next function drop. Okay, drop. Here data frame dot drop. Okay, first I'm going to remove the row index 3. Okay, to do that we need function dot drop and you have to mention the name column and the axis. Okay, axis is 0. Okay, we have seen in the earlier section on this tutorial the data frame structure. In the data frame structure, the axis 0 denotes the row and axis 1 denotes the column. Okay, now we are trying to remove the row from the data frame, so we have to pass the axis is 0. Okay, fine. Let's we have removed the row index 3. Let's check the data frame again. So here is the same problem. It's not updated in the data frame. What we can do here, so you have to pass in place keyword, okay, with true. Now check the data frame again. Okay, now it's removed. Also you can use the same function to remove the column. I'm going to remove the column 4. Okay, you have to pass 4 and you have to change the axis to 1. Okay, fine, for removing the column in the data frame and in place to update the data frame. Okay, fine. Let's check the data frame again. Data frame. Okay, now it's removed, right? So here the drop is used to remove the column or row in the data frame by passing the axis value 0 for row and axis 1 for column. Okay, fine. Okay, so far we have seen drop NA and in place keyword. So now we are going to see dot fill NA function. So to do some answer for this function, we need some data frame with blank value. So I'm going to run this cell again to create a fresh data frame with blank value. Okay, let's take the data frame. Okay, so this data frame has some blank value. Okay, fine. Now I'm going to use drop fill NA. Sorry, fill NA for the column 3. Okay, fine. Let's start with 3. Me. Okay. It's going to put the average of available value in the blank cells. Okay, fine. And I'm going to see input. Let's check the data frame again. Again, the same issue. Okay, it's not updated in the actual data frame. So we have to pass in place keyword T or UE. Fine. Let's check the data frame again. See, it's updated. The average of available column. Okay, fine. The last keyword date, pass date. Okay, to do some hands-on for this keyword, I'm going to import CSV for creating the data frame. Okay, I'm going to create the data frame weather underscore df, and I'm going to read the file which we seen in the previous section, weather.csv file. Okay, fine. The function read and as that read CSV. Okay, fine. Inside the double quotes, you have to mention the file name, weather.csv. Okay, let's also check the data. Okay, this is our data frame which we imported from our weather.csv file. Okay, fine. Let's check the data type for each cell in the data frame. Okay, by using the info keyword. Okay, you can see index is an integer data type, date column is an object data type. Okay, fine. Let's see in the action. Okay, now I'm going to use parse date. Okay, parse date, I'm going to pass the list of column which you want to convert from the object to date. Okay, fine. I'm going to convert the date here from the data type object to date. So I have added. If you want, you can add n number of column in the data frame. Okay. Okay, fine. As of now, I'm going to add only the date column. Okay, let's rerun this cell again. Okay. Let's see. Yeah, we got our data frame date column data type is date time 64. Okay, so the parse date is used to convert the data frame column from object to date type. Okay, okay, fine. Okay, thank you. I hope you guys enjoyed this session a lot. Keep motivating and supporting us to do more tutorial session like this. Okay, thank you. Bye bye.